All right, so curve sketching, this is 5.5, number 3. It is a rational function, so we haven't done one of those yet. I think we've just done mainly polynomial ones. So obviously vertical asymptotes might be a thing that we maybe haven't come across here before. So let's take a look. So section A, so we're going to do A through H, right? And A is domain. All right, so again, we're looking for values of x that are undefined or restricted. So any restricted values for x in this function. What'd you say? Okay, sorry, what'd you say? -4? Yeah, okay, why -4? Where did you look to find a restriction? Right, denominator. So we have a denominator function. So when x is in the denominator, we have to be careful that this does not equal 0 or else the function is undefined. So x cannot equal -4, so the domain, stated positively, usually that's the way it should be, is -∞ to -4, and then also -4 to +∞. That's what it can be. All right, B. B is the intercepts, right? B is intercepts. Okay. All right. So if we find the y-intercept first, that is let x equal 0, right? And then solve for y. So y equals 0 minus 4 over 0 plus 4. Y equals -4 over 4, or -1. So our y-intercept is 0, -1. And our x-intercept is vice versa here. So let y equals 0, solve for x. So if y equals 0, we then have 0 equals x minus 4 over x plus 4. And a fraction or a rational like this is only 0 when the top is 0. So you just focus on the top. There's a restriction in the denominator, but it's not going to give you an intercept, right? So let's just focus on the top. So wherever the top is 0, this whole fraction will be 0. And so x equals 4. So the x-intercept is 4, 0. Okay. Does that look good? All right. So I'm also noticing on your tests and assignments here lately that you guys you're not circling your answers. You need to highlight or circle your answers, and don't be circling more than one thing. So you need to circle your answers to declare what your answer is, because lots of times I see multiple possible answers. I don't know where you stopped, where you started. I don't know if you know what the question's actually asking. So please, for some of you, you are not circling your answers, and you think that you're done. Okay, when you're done, you think you're done. The last thing that you wrote is your answer. I don't know what the last thing you wrote is, especially when your work is all over the place. Okay, it jumps around. So you do have to declare your answer. That is a very important part of knowing and getting assessment marks for your math. You'll find that anywhere you go, you do have to declare your answer very clearly. If that's not done, then you might not get full marks. Okay, so highlight or otherwise circle the solutions for each section. Okay, that'd be very, very important. Okay, keep moving on. So what's C? What's point C? Symmetry. All right, so symmetry is point C. So that's when we test a positive and a negative x, right? So let's just test. For this one, we could test a -1. It's not a restricted value. So let's try 1 and -1, and let's see what the comparison is there. So if we had 1, we have y equals what? 1 minus 4 is -3 over +5. I'm gonna just bring this down so we can see it again here. Okay. And then a -1 would be -5 over +3. All right. So these are not the same, and they're not the same numbers but opposite signs either, right? So because that case, there's no symmetry at all. So these are not equal, nor are they the negatives of each other. So there's no symmetry. No symmetry. Okay? No symmetry. All right. Oh, my computer's lagging here. All right, D, asymptotes, right? Okay, so point D is asymptotes. So we want to find vertical and horizontal asymptotes if there are any. So the vertical asymptotes are first thing we'll focus on here. So again, in the simplified version of this rational function, which this is simplified, no factors to divide out. If there's a factor with an x that causes this to be 0, that's in there after it's all simplified, then this represents a vertical asymptote, right? So there's a vertical asymptote at x equals negative 4, okay? And that's from x plus 4 equals 0, x equals negative 4. Okay. Horizontal asymptotes. Okay, so horizontal asymptotes, if there's one, we're going to examine the limit as x approaches, let's say, infinity. And x minus 4 of x plus 4. So you might remember, hopefully you remember this, divide every term by the x with the largest exponent, which is just regular old x. And this turns into 1 minus 4 over x over 1 plus 4 over x. And as you let x approach infinity, well, 1 is going to stay 1. This is going to be 4 times 0, right, as x approaches infinity. So this is going to 0 because we have an x in the denominator. And 1 is going to stay 1 down here as well. And this is also going to race towards 0 as well as x goes towards infinity. So what we end up having is our limit is 1 over 1, or 1. So that's the horizontal asymptote. Horizontal asymptote is y equals 1. So it is important for you to write it in function form, or sort of the equation of the lines. So this is a vertical line, not a function, but a vertical line. And then this is the horizontal line. So those are your horizontal asymptote is there, vertical asymptote there. All right, how are we feeling about that? Everything going according to plan? Good? Yes, question?
Wait, so we don't have to write like bracket infinity equals 1?
You don't have to write what, sir?
Just like do as what we do as put it back into the function, like when
Are you saying about what you show for work here? Are you asking about that? Are you asking about this?
Yes.
Yeah. So if you show me that you're using this limit as x approaches infinity of the 1 over x equals 0, this is enough right here. So this is enough right here. You show me that you've changed this into this. This is as I've been teaching this, I often do this 2 lines, the 0 there. You can some people put an arrow there. That as the limit is applied, that approaches 0. You can do this as well. That approaches 1. That approaches 1. It stays 1. But if you show this kind of work, that's fine. If you write the limit for each term, top and bottom, that's great too. Yeah, but you don't have to. You can just do this as a minimum. Yeah. All right. Good. Any other questions there? All right. What is E then? Increase, decrease? Intervals of increase and decrease? Right? Increase, decrease. Okay, so here's where we actually have to start taking derivatives now. Let me grab the function here again. Copy that, bring her down. Okay, so as we take the derivative, let's take the derivative here, f prime of x, or y prime here. So this is chain rule. Quotient rule. So remember, the derivative of the top is 1 times the bottom minus the top function. So we're going to be careful with our brackets here. Minus the top function times the derivative of the bottom. times 1. I put an extra set of brackets just in case I have to do some multiplying and remember to distribute that negative sign in there. So derivative of the top times the bottom minus the top times the derivative of the bottom, all over the bottom squared, right? Okay. So when we simplify this, we get x plus 4, and we get minus x plus 4 minus an x plus a 4. Yeah. So the x's are gone. We have 4 plus 4 is 8. So that's 8 over x plus 4 squared. Now, okay, so here's another point where what you would do is show your sign analysis here, unless you can see that 8 is always positive, right? Because it's positive 8. And because the whole quantity in here is squared, this is always positive as well. So in this case, you don't need to do sign analysis. You can identify that this is always positive. It's always positive. So that means the function is always increasing. Now increasing not exactly at -4 because it's undefined, but it's increasing all the way up to -4 and all the way after -4. So just once again, if you're saying, well, I don't know if I can figure that out, what's positive and what's always negative or always positive, that's fine. Do your sign analysis. That it looks just like this. You do have to remember that you are dividing here and not multiplying. That's another little thing that you want to remember, because 8 times 0 is 0. 8 divided by 0 is undefined. So just be careful there, but sign analysis would look like this. 8 is positive everywhere. This is 0 at -4, and it's positive everywhere else because it's a squared term. And so your first derivative here is positive, and then it's undefined here. See that? Because it's 0, something divided by 0, positive number divided by 0. It's undefined. All right. Now this is where your vertical asymptote comes in. That makes sense, right? We have a positive, we have positive, 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 and then it's undefined, so it would be like, you know, an infinite slope sort of thing. Okay, so that's lines up with the vertical asymptote. So what you would say then is it's increasing, and from -infinity to -4 in union with -4 to positive infinity. Okay. Yeah, it's increasing there. Now, sometimes I kind of start the graph and plot points. I don't have the luxury of having a graph just kind of on the same page here all the time because I've got too much stuff. But you can be starting a graph anytime, like plotting your intercepts, plotting your asymptotes, taking a good look at it. You have an idea of what to expect when you do your calculus here and see if it lines up, okay? So this is what we got so far. Everybody okay with E? And of course, because it's not negative anywhere, it's not decreasing anywhere. It's always increasing. Okay, so it's going up from left to right wherever you look at the graph. Okay, F. Let's keep going. Here's F. Change my marker, please. F. Okay, so this is local min max. Local max min. All right, so obviously the first derivative test would help us out with this, and if you didn't do sign analysis, the sign analysis is the best way to look at this, so you could certainly refer to E here. Local max or min, remember, a max is where we have positive slopes of tangents, then we have a 0, then we have negative, that's the max. Minimum is when we have negative, 0, positive. And so if we look up here, right, at our sign analysis, it's positive and then undefined and then positive again. So that does not fall in any of these either of these categories. So we do not have a local max or min. Okay. Okay. So no local max or min. F prime of x is positive. Now, how do you say this? You would refer to sign analysis here. So, so let's see, first derivative sign analysis is positive, infinity, positive. Something like that. If you communicate to me somehow in a sentence or somehow like that, that there is no local max or min because you've looked at your sign analysis, that's great. And if you didn't do sign analysis, then you can do it in this section to show what you've done. Okay. So again, if you're struggling to say, well, I don't know, I just thought this, I just looked at this, well, just tell me that. You looked at sign analysis and here are the signs, so there's no local max or min. Like just some kind of indication that you're not just guessing. Okay. So again, on a test or a quiz or an assignment, communicate your thoughts. A lot of times it's showing your work. That's your communication. Totally fine. But if you have no work to show, if you're just looking at something else, just tell me what you've done. And then I'll have a good indication that you do know what you're doing. Okay? Because you can give the right answer for the wrong reasons, which doesn't display full understanding, right? So if you have the right answer, either coincidentally or by accident or you know, and your process doesn't line up with your answer, unfortunately, you're not going to get full credit. Okay. So, anyways, F. Okay. So G. What's G? Concavity, points of inflection, right? Okay. All right. So here's G. Concavity, points of inflection. Okay. All right. So here we need to find the second derivative, don't we? Okay. We need to find the second derivative. Where's my first derivative here? 8 over x plus 4 all squared. 8 over x plus 4 all squared. So our second derivative here, that's the, this is the first. Second derivative is going to be, yeah, you could do quotient rule. You could make this a -2 and do product, just do power rule, it doesn't matter. Quotient rule will be derivative of the top times the bottom, so that's just 0. Minus the top, that's 8, times the derivative of the bottom. So be careful here, derivative of the bottom, 2. So 2 times x plus 4, and then this is to the power of 2 minus 1, or just to the power of 1. Always check the chain rule. The derivative of the inside is just 1. Over the bottom squared. Okay, so what do I got here? I got 8 times 2 is 16. So I got 16 times x plus 4 over x plus 4 to the 4th. And that simplified, that goes with one of those. And so I have 16 over x plus 4 cubed. Yeah, don't forget our negative there. You're right about that. Okay, negative. Okay. Okay, so we need to find out where this is positive and where it's negative. So we have a cubed here. So changing x, you know, will probably change the whole tenor of this, the sign of this thing here. So let's do sign analysis on the second derivative. Make a space for it over here. So I've got negative 16, may as well keep that there. That's negative everywhere, so whatever, just keep that in mind. And then we have x plus 4 cubed. Now, if you want to do this x plus 4 cubed as one kind of thing, that's fine. That's fine. You just have to be careful with your signs. If you want to split it up to x plus 4, x plus 4, x plus 4, that's great too. I don't know which one you want to do, but probably most of us would be comfortable with this, so I'll just do this and walk you through this. There's just 1 0, right? So that would be at -4. And again, that's going to be in the denominator, so I usually do dotted line there to show that we are dividing by 0 here, so that's an issue. So when x is less than -4, okay, so like -10, so it's going to be a negative value in here, and then you cube it. Is that going to be negative or positive? Yeah, it's going to be negative. And then if you have a greater than 4, like 0, so 4 cubed, is that going to be positive or negative? Positive. Okay. So with an odd function, it changes. If this was an even, odd exponent. If this was an even exponent, then it would be positive everywhere, right? Okay. All right. So our second derivative then let's change color here. Our second derivative is going to be positive. It's going to be undefined because we're dividing by 0, undefined. Okay, divide by 0 here. And then negative. So what does that mean for us? Well, it means the concavity, okay, so this is concave up, this is concave down here. That's the concavity. And then the where it changes concavity, that's not a point, it's undefined. And of course, -4 has been a problem the whole question, right? So even in the original, right here, -4 is a problem. So there's no point there. It's an asymptote. So there is no point of inflection. But concavity, so you can abbreviate concave up. Okay, I'll know what CU means. Concave up from negative infinity to -4. Round brackets everywhere. Concave down from -4 to positive infinity. No points of inflection. X equals -4 does not exist. Well, f of -4, I should say. Okay. Cavity, right here. No points of inflection. Any questions about this? This is making sense? Chipping the old rust off the brain from this long weekend here we just had? All right. So that's nice. Now let's finish it off with H here. H is sketch, right? And so we want to take note of all the things that we've done so far. I don't have them on my screen, so we had a vertical asymptote. One of the important things was a vertical, oh gosh, straight lines. A vertical asymptote at what? X equals what? -4, okay. So vertical asymptote here. All right, do we have any intercepts? We had intercepts where? Okay, so -1, that's an intercept, and then over at +4, was it? Okay, so those are going to be part of the graph. Okay, there was no symmetry. Was there a horizontal asymptote anywhere? I think there was a horizontal asymptote at 1, right? So let's draw that as well. So horizontal dashed line. Okay, so you look at this now, and you know that you're not going to have a graph up here anywhere, right? You're not going to have a graph up here anywhere. Why? Because there's no intercept here. The intercept is down here and over here. So this is not, the graph's not going to be up here. The graph is going to be down here somewhere. This is a vertical asymptote, so pretty easy for us. You could do some test points too, right? -3, check what -3 is. There should be a large negative. You know the graph's going to kind of come up like this and maybe go like this, right? That's what you're thinking. Let's just as well determine, okay, moving down the list, do we say it was always increasing, this one? Right, because the derivative is always positive, it's always increasing. So this is increasing from this point, yeah. Where is the graph on the other side here? Is it over here like this? Would that work? Wouldn't, actually, because there's no x-intercept at all over here. So we don't have an x-intercept, so this is not going to cross the x-axis over here. The only x-intercept was here. And it's got to be increasing. So remember, this would be decreasing. So it can't be there. It's going to have to be up here, increasing up. Again, this is a vertical asymptote, so it's going to have to kind of come up like this, right? Just like this one goes down. And again, you could check -5 and see what that is in the function itself, right? Y equals -5, right? So -5, that's going to be what? -9 over -1. So that's +9, right? So that makes sense. It's up here somewhere. Okay, so make sure those behave appropriately around the asymptotes. We have no points of inflection. I guess the point, it changes inflection at -4, but that's an asymptote, so there's no point there. It's concave up here, that looks about right. Concave down over here, that looks about right. Okay, so anything else that you think we need here? Anything else we're missing? I think we got everything. That's pretty good. Again, if there was points of inflection, you want to label those. If there's local max or mins, because there's no local max or mins, I guess we forgot to mention that. No local max or mins, so you would label those points as well. Okay. All right, so let's just graph this on Desmos and see how close we were. Okay, so as far as a graph goes here, it looks like at -4 we definitely have a vertical asymptote there. Those look like they're bending towards. It's not going to show you that per se, but if we go up, see it's getting close to this line, but it's not going to touch or cross. And we have an intercept at 0, -1, and we have an intercept at 4, 0, so those are great. And again, if we race over towards positive infinity here, zoom way out, it looks like we have these points are getting pretty close to y equals 1, 0.94, 0.945, and so on. So if we continue on, and if we were to actually see a million, it would be, 0.9999999, right? So everything's lining up. Capiche? Yeah, everybody's good? Good, yeah. Any part of that you don't think you could do on your own? Okay. So different functions will have different challenges, right? Like local max and mins, you're going to have some critical numbers. You have to examine those, sign analysis, right? There'll be points of inflection you're going to have to figure out, that kind of thing. So, all right, so go ahead and continue on with your assignment, which is 1, 3, and 4. So I just did 3 with you. Make sure you do 1, make sure you do 4. I would encourage you to do other questions as well in preparation for the quiz and exam coming up. Okay, so the more practice you get, the better. Also look at the examples in the textbook. So the more practice you can get in, the more comfortable you'll feel. And the different kind of functions you'll see. Okay, any questions, or can I let you off on your assignment now? All right.